All right, guys, as a reminder, you have your unit test on Monday, and that's going to be your multiple choice portion where you have to look at the different graphics that are given to you, analyze the information that's given to you, and then figure out what the answer to each of the questions are. You've seen them in your pretest and you've seen them in your critical juncture. So this is just another opportunity to see whether or not we're understanding how to kind of evaluate them. We had several kind of main ideas throughout our unit. Looking here, if the objects have the same mass and their change in velocity is the same, then that means that the force acting on each of the objects has to be the same strength. So same mass, same change in velocity has to be the same force. But we also saw that if something has more mass, then in order to move that object, you're going to have to apply more force if you want the same change in velocity. So I want to get my ping pong ball and my golf ball to move at the same change in velocity, then I'm going to have to apply more force to the golf ball. Another one, if objects have the same mass, but their change in velocity is different, so two golf balls, then whichever object has a greater change received a larger force. In order to change the motion of an object, we know that there has to be a force. That was one of our vocab words, was exert. You have to push or pull the object in order to get it to change its motion, which is speed up, slow down, start, stop, or change direction. And then finally, when we have a collision, we looked at this right at the end here, the larger mass of the object, then more force is going to be in the situation. So if one object is very massive and they collide, there's going to be more force in that. Now remember, the force on those objects is equal in size and opposite in direction. But what this is saying is if I have two ping pong balls that crash into one another, the forces acting on each of those objects is going to be smaller than if I have two semi-trucks crashing into one another. So you're going to use these conclusions to kind of analyze what's going on. So you can see here you have an image. Now, if you need to enlarge your screen so that way you can see what's happening, you are welcome to do that. In this first box, you're just going to type all the observations that you see. So let's take a look at this. We have 3 boats, a blue boat, an orange boat, and a gray boat. I see that the blue boat sped up, the blue boat's speed is 3 kilometers per hour. It was 8 kilometers per hour, so it slowed down. Its change in velocity was 5 kilometers per hour. Again, I have an orange boat that started nothing. It wasn't moving. And now it's moving at 5 kilometers per hour. But again, the speed, that change in velocity is 5 kilometers per hour. So they both have the same change in velocity. Finally, we have the gray boat, and the gray boat has a speed of 12, speeds up to 17, but again, it has the same change in velocity. So we know if we're seeing the same change in velocity, right? So change in velocity is the same, then we could kind of infer that these objects have the same mass and the force acting on them is going to be the same. Okay, now you would have a specific question that you're trying to answer in your questions in your test. But for this one, we can kind of make these observations of, mass is not given, the change in velocity was the same. And so what I would want you to do, and let me go ahead and pull up the answer key here for you guys. This answer key is going to get posted for you at the end of the day on Friday, Okay, we're going to go about this a different way. The answer key is going to go through and it's going to give all the observations that we have. It's going to give all the answers to each of those, kind of that conclusion piece to it. So again, for the first one, this is kind of what we would type up. We'd say all boats have the same change in velocity. It doesn't matter if it was faster or slower, that change is still there and mass is not shown. So I could come up with this inference/conclusion. My inference is that all boats have the same mass. This is known because they have the same change in velocity regardless of the initial velocity. So then this conclusion, I've just copied and pasted from the top of the screen. So this says copy and paste the correct conclusion. I've copied and pasted from the top of the screen. So let's look at the second one. Okay, the second one here, we have a crash. So when I go back up to my inferences, only one of them is talking about when we have a collision. So that's what we're probably going to be copying and pasting. But let's take a look. So I have crash number 1. So in this crash here, I have an empty shopping cart and it says the cart has less mass and it's moving at 5 meters per second. Down here, same collision, but I have a cart that's more massive, moving at the same velocity. Well, if objects are moving at the same velocity, that should tell you something. But what I could type up here is, in crash 1, the cart has less mass. In crash 2, the cart has more mass. I can see that the change in velocity is the same. It's sped up by 3 meters per second. It's sped up by 3 meters per second. So again, when we're looking at our answer key, crash 1 had less mass, crash 2 had more mass, but they have the same change. So I can say crash 2 has a larger amount of force. And this is known because both crashes had the same change in velocity. And in order for a larger mass to have the same change, it requires more force. So then again, I copied and pasted from the top of the screen up here. I said the larger the mass, because that's our collision, and I copied and pasted that here. The larger the mass of one or both objects, the more force the two objects are going to have. Okay. So finally looking at the third one, and then you guys are going to work on your own. Looking at the third one, we have 3 hockey pucks, a green puck, a black, and a purple. I see that the green puck looks smaller, but to confirm that, it does have less mass at 100 grams. The black puck has more mass at 170. The purple puck has more mass at 170. The initial speed really doesn't matter. We really want to look at the change in velocity. And so when I look, the green puck had a change in velocity of 10 meters per second. That's where it says sped up by 10 meters per second. The black puck has a change in speed of 10 meters per second. And the purple puck has a change in velocity or speed of 10 meters per second. So what I could type up is, object 1 or the green puck has less mass. The black and the purple puck had the same mass. They did all have the same change in velocity though. So what I could type up for this one, so here we go. The green puck has less mass. Black and purple have the same. All objects have the same change in velocity. I could type up then the force on the black and the purple puck has to have been greater. And then this is known because both have a greater mass than the green, but they all have the same change in velocity. So again, I copy and pasted this from the top. If something has more mass, then you need to apply more force to move it with the same change in velocity as a less massive object. So you're going to continue through. You have 2 on each page until you get to the very end. The very last one is just looking at kind of the motion of our objects. And then you're going to go to the top and you're going to kind of tell me what you see. So continue moving through this. The answer key that I've been showing you, this answer key is going to get shared with you at the end of the day on Friday. Your copy of this needs to be turned in Google Classroom by the end of the school day. So 2:15. 2:15 is when we're going to be checking to see whether or not you got this done. You'll have today to work on it. And then tomorrow, once you are finished with the quizzes, then you can continue working on it.